All right, so now we're dealing with x squared minus 1, or x squared minus a squared, which is going to give us our secant squared. So you can see the x squared is first this time. So that would give us secant squared minus 1, which we can then convert to a tangent squared. So that's why we want to start with x equals secant theta. And so we're using, again, our a being 1 here. And so dx is equal to secant theta tangent theta d theta. And now we can plug it all in and see what we get. So we have secant squared theta minus 1 under the radical. Our dx is secant theta tangent theta d theta. And our x squared then would just be secant squared theta. So again, the whole point of this was to get rid of that radical. And so we can do that same thing we did before. So secant squared theta minus 1 is tangent squared theta, which means this would just be tangent theta. So now we do some simplifying, and that secant cancels there. So we end up with tangent squared theta over secant theta. And then we can just replace that tangent again with secant squared theta minus 1 over secant theta. And the reason I'm doing that is that way I can divide. So this would become just plain old secant theta minus 1 over secant theta, which would then equal secant theta minus cosine theta. And those we can take the integral of. So we know secant theta's integral is the natural log of secant theta plus tangent theta. And the integral of cosine is sine. So minus sine theta plus c. So now we go back. Secant theta is equal to x. We make our little triangle and put theta, and so that's x over 1. So this would be the square root of 1 minus x, oops, backwards, square root of x squared minus 1. See, it's right there. All right, so what do we need? We need secant. Done. We need tangent theta. So tangent theta would be square root of x squared minus 1 over 1. You can put the 1 if you want, but that's just square root of x squared minus 1. And then we also need sine theta. So sine theta is equal to square root of x squared minus 1 over x. So now we just have to plug them in. Let me get some more room here. There we go. So we end up with natural log of secant theta. Secant theta is just x plus tangent theta, which is the square root of x squared plus 1, minus sine. And sine theta is the square root of x squared minus 1 all over x plus c. Now you could have converted these as well to sine and cosine and then canceled that way. All right, let's try another one. So again, here is a little bit more complicated. We now have a 9x squared minus 1. So when we plug this in, we need to get rid of that 9. So how that works is this. We want our 9x squared to equal secant squared theta. And so I like to write it that way. So if you look at it this way, this means that 3x would equal secant theta. So that means we need to pick our x, this is what we want, to be 1/3 secant theta. So if you just basically solve for x, don't worry about the negative because we're picking this. This is where we're actually starting, not here. It tells us what we want to use. So x equals 1/3 secant theta. So dx is equal to 1/3 secant theta tangent theta d theta. And now when we plug it in, it'll work out perfectly. Okay, so this becomes 9, and then you'll see that's 1/9 secant squared theta. In fact, you could even just say, look, if this is this, 9x squared is secant squared. In fact, that looks a lot nicer. So why don't we just go that way? Secant squared theta minus 1 over. But then now that's an x, so we have to use this one. So that would be 1/3. And I recommend just leaving it like this. You'll see why when we start to simplify. And then 1/3 secant theta tangent theta d theta. All right, now we're going to put it all together. So on the top, that becomes tangent with a tangent is tangent squared. So 1/3 secant theta tangent squared theta. And then on the bottom, we have 1/3 cubed secant cubed theta d theta. And so now we can cancel. That one takes out one of those. That one takes out one of those. So we end up with tangent squared theta over, and that's 1/9 secant squared theta d theta. All right, now we just have some rewriting. So 1/9 flipped would become 9. Tangent is sine squared theta over cosine squared theta. So we need to do some canceling. So again, you could write tangent squared as secant squared and separate it, or since we did that on the last one, I want to do it a little differently this way. So reciprocal of secant squared is cosine squared. And then now we just cancel. So we end up with 9 integral sine squared theta d theta. All right, and then obviously we use our double angle, so 9/2 integral 1 minus cosine 2 theta d theta, which would be 9/2 theta minus 9/4 sine 2 theta plus c. And if we double check this, this would become 9/2, 1, perfect. And then that would become cosine 2 theta times 2, which cancels with that, gives us 4th. All right. So now we just go back and do our quick little replacements. So right here we have x equals 1/3 secant theta. That means that 3x equals secant theta. So when we do our triangle, secant again is hypotenuse over adjacent. So what we would have over here is 9x squared minus 1. Now we need sine 2 theta. Sine 2 theta is equal to 2 sine theta cosine theta. So this again would be 2, and then sine would be square root of 9x squared minus 1 over 3x. Cosine would be 1 over 3x. So this becomes 2 square root 9x squared minus 1 over 9x squared. Okay. And we also need theta. So theta here is used right there. So secant theta equals 3x is what we're going to be using. So that means theta equals inverse secant of 3x. Now we could have also done an inverse cosine of 1 over 3x. That's your choice on what you want to use, but we're going to use the secant because that's what we have. Inverse secant of 3x minus, now I'm going to plug it in, and then we'll do a little quick because there is a 9 here. 2 square root 9x squared minus 1 and a 2. All right, so that's going to cancel. So I'm just going to do a quick cancel, 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 and erase. So this would have been 2. So what it really is a 2 on the denominator. So we get rid of all that, and we place the 2 plus c. And there we go.